We're going to start by reviewing the numbers of the decimal system. With the numbers of the decimal system, we can represent very large numbers as well as very small numbers. We're going to use scientific notation to facilitate the representation of these numbers. They're based in powers of 10. So we start with number 1, that is 1 to the power of 0. If I now want to represent 12 in powers of 10, then I have to move this point one position to the left, so that I can write 1.2 to the power of 1. If I want to represent 123 on powers of 10, I have to move 2 positions to the left, so I can write 1.23 times 10 to the power of 2. Now let's look at a fraction, 0.1, and I want to express this in powers of 10. So I need to move 1 position to the right, so I can write 1.0 times 10 to the minus 1. Now with the numbers 0.012, I need to move 2 positions to the right, so that I can write 1.2 times 10 to the minus 2. And one last example. To write this number in powers of 10, I need to move 3 positions to the right, so I can write 1.23 times 10 to the minus 3. Now let's try with a large number. We need to move this point several positions to the left in order to express this in powers of 10. So let's count 3, 6, 9, 12, 15, 18, 19, 20, 21 positions to the left. So I can write number 1.234 times 10 to the 21. If I want to do the same for the small number in powers of 10, I need to count all the positions that the point needs to move to the right. So that would be 3, 6, 9, 12, and then 0 there will be at position number 15, so I can write 4.321 times 10 to the minus 15. Now, in engineering, we use engineering notation. Engineering notation is a form of the scientific notation where a number can be written with 3 digits to the left of the decimal point, and the power of the 10 exponent must be a multiple of 3. So, for example, if we have 25,000, then I can move 3 positions to the left, and that will be 25 times 10 to the power of 3. Let's look at this small number. I can move 3 positions, and I will have 0.25 to the minus 3, or I can move 6 positions, and then I can have 250 times 10 to the minus 6. For the next number, I can move 3, 6, since we move in multiples of 3, and so this will be 2.5 times 10 to the 6. Again, multiples of 3 will be 3 and 3, and this will be 2.5 times 10 to the minus 6. Now, we use what is known as metric prefixes, and these are just worded expressions of our powers of 3. And so, if I have 25,000 volts, I know I can express this as a power of 3 as 25 times 10 to the 3. But the metric prefix is 25 kilovolts. Now for the small number, 0.25 or 250 times 10 to the minus 6, that will be 250 micro. 10 to the minus 6 is micro. And now the 2.5 million ohms, we move these 3, 6, that will be 2.5 times 10 to the 6, and 10 to the 6 is mega, so we will have 2.5 mega ohms.